Okay, in this video we're going to work the review for Chapter 2 that's in the Big Ideas book. So let's get started. One of the first things that we did, it was in Chapter 2.1, is we transformed quadratic equations. Now remember, quadratic equations are always going to be the ones that they will have an x squared term in there, and that will be the term with the highest exponent, but they're all going to look like parabolas. So this is function notation, and what that's saying is we have a function of x, and of course it doesn't have any shifts or anything, so that would be my parent. And then if I see something written like this, all it's saying is what I'm doing to the function is I'm adding a negative on the outside of the function, so that would be the equivalent of having a reflection, and it would change the y value, so that would be a vertical reflection where the parabola is flipping downward, so that would go across the x-axis, so this would be a reflection over the x-axis. And your book doesn't say over, it uses the term in the x-axis. When we see the a value, like it's shown here, that's a times the function, that's going to be a stretch or a shrink, and of course it's going to affect y, so that's going to be a vertical because the y-axis goes up and down, right? So anything that's affecting the y is up and down, that will be a vertical. Stretch or shrink by a factor of a. Here we're going to have a shift in the y direction, which again would be a vertical shift. Now we're going to call that up or down. So this is a shift up, down by k units. This here has a negative inside it's affecting the x, so that would be a situation where somehow or another you would see that the negative is inside the squaring like that, and that would be horizontal because x is a horizontal movement. So this would be a horizontal a reflection horizontally, which would go across the y-axis. So this is a reflection. Over the y-axis. And again, your book would say something like in the y-axis. And the last thing that we have, and actually it looks like I left off a stretch or a shrink in the x, but we'll get that here in a second. And if I have something that looks like this, that's going to be a shift in the x direction, which would be a shift left or right h units. And actually it would say x minus h because it would be the opposite sign. So let's correct that. Okay? And maybe I ought to add one more here. Let's see how much room I have. Another one, the last one I'll show is if I have something that looked like f. That's going to be a shrink or stretch in the x direction, and actually what we would have is, remember, it's the reciprocal of the c. So, and since it's in the x direction, it will be horizontal. So this would be a horizontal stretch or shrink by a factor of 1 over c. Okay, let's go down to the next piece. Now the x shifts and shrinks are pretty complicated because whether you have it written like this, where the stretch or shrink is outside of the parentheses, here's the shift, and here's the stretch, or you multiply the c into the x, so you have cx, and the c would multiply by the h, and you'd actually have ch here, I guess. And now the order at which you do these changes depending on how it's written. In this particular one, the first one, you would do the stretch and the shrink first, then the shift. In this particular one, you would do the shift first and then the stretch or shrink. So when you shrink it, it actually does affect the shifting. So for what we're going to do, we're going to focus on the first type where the C is going to be outside of this, the shift, which means that we would do the shrink first or the stretch first and then do the shift. And because this is a little more complicated than I really think is necessary for the Algebra 2, we are not going to do an X stretch shrink at the same time that we do a shift. We'll wait for pre-calculus to do that. And so I kind of explained some of that in here, so you can stop the video if you want. But basically down here are the way that we'll look at it. In this one here, you see that we do have a reflection and a stretch or shrink in the X direction, but I don't have any shift. Over here, I have a shift, but I don't have any stretch or shrink because there's no C value. So to keep it simple, we'll just either deal with one or the other. Now in both these type, this is what we're going to have. Let's look at this negative sign. Remember what, so this is kind of how you'll see the equations written. This negative, that's of course going to be a reflection across the X. The A value, remember, that's a stretch or a shrink vertically, so that would be this negative sign. Remember, that's going to be a reflection across the y-axis because it's affecting the x value, so it's going to flip it across the y-axis. And let's see what we have here. We have the C value. Remember, that's going to be a stretch. Wait a second. I'm just talking and not thinking here. The negative sign on the X, that's a reflection across the Y. The C value will be a stretch or shrink. And since it's affecting X, it will be a horizontal. This K value, that's going to be a shift up and down. Okay, going to the other kind that we may have, where we're not doing an X stretch or shrink, but we're doing a shift. Remember, this is going to be a shift for the X, right, which would be horizontal. And it'll be left or right. Okay, so let's look at some examples. Here's one, and what we see is that we have a negative outside. Now look, the parentheses are here. The negative and the 4 are not in the parentheses, so this is a Y effect. So the 1 will be a reflection. Across the x-axis. Then we've got a 4, which is a Y effect. That's going to be a stretch because it's greater than 1, and it's going to be vertical because it's a Y effect by a factor of 4. Then we have this plus 1. Now remember, when it's dealing with the x, it would be actually the opposite side. That's h, right? So we've got h is equal to a negative 1. So that's going to be a shift to the right 1 unit. And then lastly, we have the fourth thing that's going on here, and we can see that's the k value. That's a negative 5. So that's a shift down 5 units. Okay, moving to the next problem. The first thing here, we have a negative on the outside of the parentheses, so that's a reflection across the x-axis. We have a 1/2 multiplier, so that's going to shrink the y value, which would be a vertical shrink. Right, so remember, we have to put the term shrink since it's going to actually, the y will decrease. So don't put stretch by a factor of 1/2, put shrink. The third thing is a negative inside the parentheses, so that's going to reflect across the y-axis. The fourth thing is that we have the inside the parentheses, x is multiplied by 1/4, so that's actually going to be the reciprocal, so it'll be 4 times x. That's going to be a stretch horizontally, because the x is a horizontal movement. And lastly, we have this k value, so k is equal to 3. That's going to be a shift up and down, so it's going to be a shift up 3 units. Okay, the next piece. And here we're going to we're given a description of what's going on, and we have to write the equation. So for the first thing, it says a vertical stretch by a factor of 4. Vertical, that's y. So it's going to be outside the parentheses. Okay, so I know that it's going to be 4 times whatever in the parentheses. That's the first thing it's got. And then it says a reflection in the x-axis. So that's a reflection over the x-axis. That would be a negative on the outside. And then followed by a translation of 2 units up. So it's moving 2 units up. That's going to be a y shift, so plus 2. And here in the parentheses, then nothing's going on. So this is what it would look like. And to rewrite it in a little bit simpler form. Now remember, this negative 4 is not affecting the x value, it's affecting the y. If it was affecting the x, it would be inside the parentheses with the x. Okay, let's go on to the next one. And let's just set the thing up. We're going to have a parentheses. And let's give this a shot. So we start out, it says a vertical shrink by a factor of 1/3. Vertical, that's y. So 1/3 on the outside. Followed by a reflection in the x-axis. So a reflection over the x-axis would be a negative on the x, followed by a translation 3 units down. So that'd be a minus 3. So that's what my equation would look like. Okay, let's see what else we got next. Okay, now it looks like we are plotting in standard form. Okay, so when I do standard form, what we're going to do is we need to find a, b, and c. Remember, the standard form of equation is y squared is equal to ax squared plus bx plus c. All right, so let's go ahead and figure out the steps to plot this. So the first step is we need to find the axis of symmetry. Okay, so the axis of symmetry is going to be at x is equal to a minus b all over 2a. So in this case, it's a minus b. That's a minus 1 all over 2 times 0.5. And that would be a negative 1 all over 1. So the axis of symmetry is a negative 1. And let's go ahead and put that on the graph and label it. So my axis of symmetry is x equal a negative 1. Okay, now my vertex needs to be on the axis of symmetry, so I can go ahead and start getting my vertex. I know the x-coordinate of the vertex is going to be a negative 1, but I don't know the y. Well, anytime I know x and I want to find y, I just put the value of x into the equation. So what I'm going to do is I'm going to substitute the value of x, which is a negative 1, into this x squared, so I get 0.5 times a negative 1 squared plus x, so that would be plus a negative 1 minus 3. So that would be 0.5, 1 squared is 1, times 1, minus 1, minus 3. So 0.5 times 1, that would be 0.5, minus 1, minus 3. 0.5 minus 1 would be a negative 0.5 minus 3, so I have that equaling to a negative 3.5. So my vertex is going to be at negative 1, negative 3.5. We always label our points. Okay, now I need a second point. If I look at this equation, I can see where it's going to cross the y-axis. If I put a 0 in for x, I get a negative 3. So that would put the point right here, and that's just too close to this other point. I don't get a good view of what the parabola shape is going to look like. So I'm going to move over to the right some and try to find another point. Maybe like x is equal to 2. Let's try that. So x is equal to 2. So here I'm going to plot my second point. And I'm going to say x equal to 2. So let's plug 2 into this equation. So I got 0.5 times 2 squared plus 2 minus 3. 0.5 times 4 plus 2 minus 3. So 0.5 times 4, that's 2, plus 2 minus 3. 4 minus 3 is equal to 1. So when x is 2, y is 1. So 2, 1. That would be my second point. I can get my third point by either picking an x value, putting it in and getting y, or try to see if I can get the mirror. What we see is we got 1, 2, 3 on this side of the axis of symmetry, so 1, 2, 3. On the other side, there'd be another point. Remember, this point was 2, 1. This point would be a negative 1, 2, 3, 4, 1. So in this case, the third point, I did my mirror, and I got a negative 4, 1. So I'm ready to draw the parabola. Okay, and the domain is going to be all real numbers, which in interval notation would be written like this. The range is going to be all real numbers greater than a negative 3.5, so y is greater than or equal to a negative 3.5, and in interval notation, that would look like this. Okay, let's go on to another problem. And this is another standard form problem. And so let's go ahead and start. First thing is to find my axis of symmetry. And so let's go ahead and put A is equal to -1, B is equal to -6, C is equal to 3. You can read those right off the equation. So my axis of symmetry is X is equal to a negative B all over 2A. That would be a negative B, so negative of a -6 all over 2 times A is a -1. So I have 6 all over -2, so it's a -3. So my axis of symmetry is a -3. Okay, now let's find the vertex. The x-coordinate is a -3, so let's plug a -3 into the equation. So I have y is equal to a negative of a -3 squared minus 6 times a -3 plus 3. That's going to be equal to a -9, because -3 squared is 9, plus 18 plus 3. And that's going to be equal to a 9 plus 3 is 12. So this one's going to go off my graph a little. So I'll just have to deal with it. So my point is a -3, 12. So -3, and let's just put it up here. Okay, let's find second point. And what I'm going to do is, the first thing I'm going to do is scan this equation up here and look at my y-intercept, right? If x is 0, y is 3. And I can see that that's actually pretty far away from this point that I just plotted the vertex. So I'm just going to use that. So I'm going to use my y-intercept point. That would be 0, 3. So 0, 1, 2, 3. My third point I'm just going to use the mirror. So it's 1, 2, 3 on the right. So this will be 1, 2, 3, 1, 2, 3 on the left. That would be the point 1, 2, 3, 4, 5, 6, -6, 3. And we're ready to draw the parabola. The domain, like before, is going to be all reals. In interval notation, it'll look like this. The range, you can see that it's all the y values that are less than or equal to my vertex, which is 12. So how I would write that in interval notation, we're going to say it's a negative infinity all the way up to 12 with a closed bracket on the 12. Okay, next problem. It looks like I'm plotting in vertex form. So this form is easier to plot because I can just read the vertex right off the equation. So h is going to be equal to a -1, k is equal to a -3. My axis of symmetry will be whatever the x-coordinate of the vertex is. So my axis of symmetry is x is equal to a -1. Let's go ahead and put that on there. So I'll write down here. And my vertex is going to be at -1, -3. Okay, so let's get a second point. I can pick any point I want. I will need to have it a little bit further away from this vertex, so I'm just going to try to see what happens when I put x equal to 1. So I'm just going to say x equal to 1, and I'm going to plug it into this equation. So y is equal to 2 times 1 plus 1 squared minus 3. 2 times 1 plus 1, that's 2 squared minus 3. So that would be 4 times 2. 2 squared is 4, times 2 is 8, minus 3, I get 5. So when I pick x equal to 1, I get a value of 5, so my second point would be 1, 5. Okay, let's put the labels on there. And I'm going to use, for a third point, I'm going to use the mirror again. So it would be 2 on this side. That would be a negative 1, 2, 3, 5. Okay, so I can draw my parabola. The domain, all real numbers. Which in interval notation is written from negative infinity to infinity. And the range is all real numbers where y is greater than a negative 3. Okay, let's do another problem. Here we have intercept form. And what we're going to do in this form is the first thing is we're going to find out where it crosses the x-axis. So we're going to basically set y equal to 0. And we're going to figure out what values of x make this equation go to 0. So what we would have, and we would have a negative 1. So right here, this value of x, if it was a negative 1, would cause this factor to go to 0. So one of my intercepts would be a negative 1, 0. The other x-intercept would be what would make this factor go to 0, which would be 3. So I have 2 points I can already plot. Those are my x-intercepts. They're at a negative 1, 0. And I have one over here at 3, 0. And now what I need to do is find my axis of symmetry and my vertex. The axis of symmetry will be halfway between those. So there's 2 ways to do that. One way is I could simply just average the x-coordinates, which would be 3 plus negative 1. Of course, it's an average divided by 2. That would be 2 over 2 is equal to 1. So if you have fractions, that may be the way to do it. But another way would be just to find out what's in the middle, 1, 2, 3, 4 divisions, so halfway between there would be where my axis of symmetry is, so here it is. And I know my vertex is going to be on that axis of symmetry. So I know the x-coordinate of my vertex will be 1. To find the y-coordinate, I'd simply plug it into the equation. So y is equal to, the x value would be 1. No, negative 1, sorry. Negative 1. Let's try again. It's 1. 1 plus 1, 1 minus 3. That would be 2 times a minus 2, which would be equal to a negative 4. So my vertex is at 1, negative 4. And I have my parabola. Okay, let's get the domain and range. Domain is all reals. And the range are all the values where y is greater than, oh, I didn't put the value of my vertex on there, so that was where y is greater than or equal to a negative 4. Here's another one. I'm not going to plot it. I believe this one may run off the graph. I can't remember. But anyway, let's just try to find the intercepts and we can plot those, and then you know how to find. We just did an example. So for here, the value that would make this x go to 0 would be x equal to 0. So my intercept would be 0, 0. The value that would make this x go to 0 would be x is a negative 7. So my other intercept would be a negative 7, 0. So I could put 0, 0. Negative 7, 0, and halfway between there would be my axis of symmetry, so that would be at a negative 7 and 0. The average of that would be a negative 3.5. And since this 4, that would be a stretch factor, this one gets really, the vertex should be way off the graph. So let's just leave it at that. Let me just cover this real quick on how to do it. I'm not going to get into plot it so that the video doesn't get any longer than it already is. This, we can think of this equation as looking like, well, actually, if I would see this, I would just plot it in vertex form. I could plot it in intercept form by thinking of it like -2 times x minus 3, x minus 3. And then what I have is I have two intercepts, but they're both at the same point, where x would be equal to 3. And then we would have to plot it slightly different. But the best way to do this one is just to look at it and say, okay, I don't like the way intercept form looks. It's going to be a little bit hard to plot since I only have one intercept. It's the same point for both of those. And so I'm just going to plot it in vertex form, which we did above. Okay. I'm going to put this on hold and pick it up again because it's time to go to work. Okay, what we're doing in these problems, as we are finding the minimum and maximum value of a quadratic equation, and that's going to occur at the vertex, right? So if I had a parabola that opens downward, the vertex is a max, and that would be when the number in front of the x squared is negative. If it's a positive number, it's going to open upward and the vertex will be a min. So what we're really doing here is finding the min and the max. So let's go ahead and look at this one. What we have here is we could look at this so this is actually, we can think of this as vertex form. So the vertex of this one, h, is 0, k is a -1. So my vertex, and let's just kind of make a rough sketch of this, it's going to be opening up because this is a 6 in front of the x squared and it's not negative, is my vertex is going to be right here with an axis of symmetry of x equal to 0, and the vertex point is 0, 1. So we can see that it's a minimum, right? So I have a minimum, and the y value at that minimum is 1. So what this question is asking is, what's the y value? And so the minimum is equal to 1. It also says, where is it increasing or decreasing? Well, it's going to be doing whatever it's doing on the left-hand side of the axis of symmetry, the opposite will be happening on the right. So what we do is we break this into two separate sides. The left of the axis of symmetry, so we would have x is less than 0, and the right-hand side where x is greater than 0. And on the left-hand side, you can see that we're going downward, so it's decreasing. And on the right-hand side, it's increasing. So note that I didn't put x equal to 0 because right at the vertex, it's not increasing or decreasing. So what we have to do is we don't use an equal to sign on either side of this axis of symmetry. And the last question is the domain and range. The domain, of course, is all real numbers. And the range is going to be where y is greater than or equal to the vertex. So y greater than or equal to 1, which in interval notation would be written one infinity. Okay, next problem. Okay, see, it's got a negative in front of the 3, so this is going to be a parabola that opens downward. So the vertex will be a maximum. So we need to find the vertex. That's going to be at a minus b over 2a will be the axis of symmetry. So it'll be a minus b over 2a. That will be a minus of a negative 6. That's the b value. And 2a would be 2 times a negative 3. That'll be 6 all over. A negative 6 would be a negative 1. So the x-coordinate of the vertex is negative 1. The axis of symmetry is x is equal to a negative 1. Let's find the y value by putting a negative 1 into the equation. Negative 1 squared would be 1. This would be plus 6, plus 5. That would be equal to 8. So my vertex is a negative 1, 8. Since the vertex is a maximum, the maximum value of this equation will be the y value. So the maximum is equal to 8. On the left-hand side of my axis of symmetry, that would be where x is less than a negative 1. On the right-hand side will be x is greater than a negative 1. We can see that it's increasing on this side, and it's decreasing on this. My domain and range, domain is all reals, which in interval notation is written like this. And the range would be where y is less than or equal to the maximum value of 8, which would be in interval notation. Okay, let's go to the next problem. Okay, now we're getting into some word problems. And what we see is that we have an equation of this field here. And what we need to do is we need to find out what the width of the field is and what's the maximum height. Well, when we have a quadratic equation that looks like here, there are several important values. Think of this as the ground. Then this is going to be an x-intercept crossing the x-axis. This is going to be an x-intercept. And the maximum is going to occur here at the vertex. So I need to find all three. So the equation that I'm dealing with is y is equal to a negative 0.000234x times x minus 160. So the intercepts will be what values of x make this go to 0? Well, here's one of the values right here. That would be x equal to 0. And another one from this part would be x is equal to 160. So what we see is that here's the start of the football field. Here's the other side. So the width of the football field would be 160 feet. And what we need to do now is we need to find this vertex. The vertex, or the maximum height, is going to occur halfway between 0 and 160. So right in the middle, I'm going to be at my maximum height, which would be 80 feet on x, and I need to find the y value for how high is that football field. So I'm going to put 80 into this equation. Okay, so I'm going to put it on hold while I calculate that out. Let's go ahead and write it. Y is equal to a negative 0.000234 times 80 times 80 minus 160. So all I've done is substitute 80 in, and what I got was 1.5 feet. Okay, so this vertex would be 80, 1.5. So the football field is domed such that it's up 1.5 feet higher in the center. Okay, another kind of word problem is, let's see what we have here. We have a frog that's jumping, and this is the equation that models its jump, where x is the horizontal distance. and y is how high that it goes. And it says, can the mouse jump over a fence that is 3 feet high? So here's the mouse's jump. Here's where it starts. Here's where it ends. And the vertex will be halfway in the middle. So we need to find the height at its maximum, right? That's the maximum height. So we could do this one in several ways. I'm going to go ahead and consider that it's in standard form so we can find the vertex a different way. Remember that the x-coordinate of the vertex in standard form is x is equal to a minus b all over 2a. So in this case, b would be equal to 1.3, so that's a minus 1.3. And 2 times a would be 2 times 0.2. Okay, that would be a, and it would be a negative, right? Because it's a is negative. So this should be 1.3 all over 0.4, which I have as 3.